Angie Jones. Angie is a Java champion and a senior director at Applitools. She specializes in test automation strategies and techniques. With a passion for teaching, she talks at conferences, writes blog posts on her site angiejones.tech, and even leads an online learning platform, the Test Automation University. She also has over 25 patented inventions in the US and China, which just amazed me, by the way, when I read her bio. And yeah, in her spare time, she volunteers at Black Girls Code to attract more women and minorities to tech. And today, she will be talking about her favorite new feature since Java 8. Angie, welcome to the stage. Have fun. You're on mute.
All right. Thank you so much. Hello, everyone. I'm Angie, and I love Java. I teach free courses at Test Automation University, including Java programming. So if you need someone who needs core Java skills, send them on over there. Selenium WebDriver with Java, visual testing with Java, and a couple of others as well. Now, while Java is still, a leading programming language, it has gotten a bad rap over the years. And some of the biggest gripes that I've heard are things like Java is too verbose, meaning, yeah, we have to write a lot of boilerplate code to do, some pretty basic things. I've heard that the language was not evolving fast enough. For example, the releases of Java 7, 8, and 9 were all 3 years apart, which is almost a lifetime in software development cycles. Good news is that the powers that be have heard us loud and clear, and Java has gotten a much needed makeover. And now new versions of the language are being released every 6 months. The latest release of Java is version 16, which was released in March. And yet, so many developers that I speak with are still using Java 8, which is understandable given, certain work restrictions. But with so many new features, it may be hard to keep up with what's you know going on in the language. So in this talk, I want to demonstrate some of the newer features of Java and how we can take advantage of them. Okay. All right. So we are actually going to look at some automation code for verifying this banking page. And the specific test that we'll go over today is just going to make sure that all of the accounts are listed as we see here. Okay. So here is our test code, and I'm going to walk you through it. This is in Java 8. All right. We are logging into the application, and we get a handle to this accounts overview page. And this is where that table of accounts is located. And then next, we get a list of the account numbers that are displayed on the page. And then we want to get the expected accounts. So the test data can change. So we're actually going to make a call to an API to get the expected accounts. And this returns a list of deserialized account objects. So we want to make a new list, which will only contain the account numbers as strings as opposed to the entire account. And then we'll loop through the list of account objects and add the account number from each account into our list of expected accounts. Okay. And then finally, we compare both lists, make sure every account for this customer is actually shown on the site. So again, this test was written in Java 8. What we'll do is go through this and see how we can modernize it using some of the latest features in Java. You ready? Okay. So we'll start here with the declaration of the accounts overview page. And as you can see, we're following Java conventions. We're using good names for both our class and our object. However, many times, as we see here, these two names end up being the same thing, right? So this is redundant. It makes for a lot of typing. So in version 10, Java introduced type inference for local variables. And what this means is that instead of explicitly declaring the object or variable's type, we can instead use this keyword var, and Java will infer what the type is based on what's being assigned to it. Okay, this is probably my favorite new feature in Java because we always have these long class names, and now we no longer have to type all of that out. So it's really nifty. But before you get carried away and start using var everywhere, let me explain the rules and also give you some tips. Now, this doesn't make Java a dynamically typed language like JavaScript or Python. The type is still there, it's just inferred from the right hand side of the statement, which also means that you can only use var if you're actually initializing the variable. Otherwise, Java is not going to be able to infer what its type is, right? So that makes sense. Also, it only works for local variables. So you can use this inside of methods, loops, decision structures, but you cannot use this for global variables, even if you're initializing them. Okay. While local variable type inference can be used within the body of local constructs, it cannot be used in the headers of methods or constructors. And this is because whoever's calling you needs to know the data type of the arguments that they need to send. Okay, so those are the rules. Now let's get into some guidelines. Given this variable name and this method name, I have no idea what the inferred data type of X would be, right? Sure, Java knows, but me as the reader, I can't easily tell what this is. So this makes it really difficult to work with this variable. Now, you should always use good variable names, but it's even more important to do so if you're going to use var, okay? Once you start using this, you're gonna love it. But again, please don't overdo it. So, for example, using var here, this doesn't do you any favors, right? Int is 3 letters, var is 3 letters. Just go ahead and type int there. Okay. Now, I've updated our test method to use vars. So I'm using var here, and the inferred type is very clear to me as the reader because of the variable name I chose, right? Here, I changed the variable name from actual accounts, which was okay when given the type context. I changed it to actual account IDs list so that it's clear this is a list and it's holding the account IDs. All right. For this one, I also changed the name from accounts to accounts list. Again, so that it's clear this is a list holding account objects. Here, I changed the name to be more representative, and I also explicitly define the data type of the array list on the right hand side. If I didn't use this diamond operator to indicate that this is a list of strings, then it would have been inferred as a list of objects, right? Which is okay in this case, but you can imagine how you might get yourself into some trouble down the road. For example, if I needed to get one of the elements from the list and use the dot operator, expecting some of the string methods there, I only would have access to the methods within objects. So that's why I explicitly defined it on the right side to just kind of help Java infer the right thing there. And then here I'm using var inside of a for loop just to show you that that can be done as well. Okay. Okay, what else can we modernize? How about let's look inside of this get accounts method. Now, remember, this is the table and we're getting all of those values in the first column labeled account. And here's the code to do so in Java 8. All right. Um, we see here that it finds all of the account sales, and these are web elements. Then it creates a new list to hold just the text of the web elements. So this is essentially a list of strings. And then to populate that list, we loop through each of the elements from line 3. We get their text, and then we add them to our new list on line 6. Okay. Notice this method needs 2 lists and a loop. There's a more modern approach to do this in Java by using functional programming style. So this approach was actually added in Java 8. I don't see it a lot in test code. I don't know how many of you are using it, so I'm going to highlight it just really quickly. As you can see, this is much more streamlined. Here we still call find elements to get the list of web elements, but we don't need to store them. Instead, we turn them into a stream from which we can do some cool functional programming. And this map function will take those web elements and map them into whatever is passed into this. So here we're saying get the text from these web elements and then store them into a list, which we return. Cool. Here is an alternate way to write the map call. Notice in the top example, line 5 uses a shortcut or a syntactic sugar, as we like to say, but in the bottom example, line 3 uses the fully spelled out approach. Okay. All right, so we can do the same thing in our test method. So instead of using the 2 lists in a for loop, I use a stream and I map what I need into a single list. Good stuff. Now, it's a good practice to break up these chained method calls where each method falls on a new line, right? And it's really tempting to do like this, big, powerful call all on one line because it's like, wow, look at my wicked one-liner, but it makes it harder to read your code and process what it's actually doing. And if you're using an IDE like IntelliJ, you can add, breakpoints on these chain calls if you break them up this way. So it's a good practice to just break it up. And let's look at what's new with streams post Java 8. So Java 9 introduces a couple of new methods to stream, one being take while. So let's say that I have this code which gets the list of accounts, and then it uses the take while method on this stream of accounts. Within this take while method, you pass in a condition, also known as a predicate. And this is saying to go through this list of accounts and accept all of the ones that have a type of checking until you get to one that does not have this type. So here are all of the accounts stored in accounts list. And notice there are 11 of them. And when we say take while type is checking, we end up with a list of 3 accounts. And as you can see, it's the first 3 accounts from the accounts list. But when it got to that 4th account, the type was savings. So it didn't match. And the stream ended then. Okay. All right. Java 9 also introduced drop while, which does the opposite of take while. For this one, we're saying drop the accounts of type checking until you get to one that's not. So with the 11 accounts here, we see the first 3 are checking, the 4th is savings, 5th through 9th are checking, 10th is savings, and the last one is checking. All right. So how many accounts do you think will be collected here in checking accounts list? I'm going to give you a moment to get your guess together. Okay. All right. You ready? If you said 8, you are correct. So this method dropped the first 3 accounts because they matched the predicate. And then it stopped the stream once it hit the 4th one because that did not match the predicate. So all other accounts are then collected and stored into the list. Okay. Now, all of the accounts couldn't fit on the last slide. So here's the full list of drop while account type is checking. All right. So you might be thinking, well, Angie, why on earth would I want to use take while and drop while, right? The examples I showed you were a bit of a brain tease because the lists weren't sorted, so the results were indeterministic. However, if you sort the collection first, as we're doing here, it makes a lot more sense. And notice I'm using this comparator to specify which property I want this object sorted by. Okay. So given the sorted list, we see that it collects all of the checking accounts, and this actually makes more sense in practice. Likewise for drop while. Okay. All right. So let's see what else we can modernize. How about let's look inside of this get customer ID method. So this method is holding our test data, and based on the name on the account, it's returning the account ID. Okay. This is using switch statements. And notice we have to declare the variable, and then we specify each case we want to handle. And inside of the case, we assign the value to ID, and then we must follow the assignment by a break statement to prevent fall through to the next case, right? Which would override the variable. Not only is this a lot of boilerplate code, it's also risky, right? If you forget one of those break statements, then it returns the wrong ID. And I'm sure we all have been guilty of this before. In Java 12, switch expressions were introduced. Now you can use switch to directly assign a value to a variable. So notice here we're using switch on the right side of the statement to initialize this variable. The case statement doesn't need a colon in switch expressions, but instead it uses an arrow. And this is saying if the name is John, then assign 12212 to the variable ID. Notice I don't need a break statement, right? There's no fall through with switch expressions. And I can even simplify this a bit more by removing the assignment here and just returning the result of the switch expression. Okay. Now, using the lambda style arrows is one way to assign the value, but you can also use another approach. You can use the colon that we're used to, but you'll need to follow it with the word yield. Okay, this is a bit more verbose, so I prefer to just use the arrow, but I'll show you where yield comes in handy. All right. So you can specify more than one case. Notice here we're saying if the customer name is John or Demo, which is his last name, then the ID is 12212. So this makes up for the removal of fall through from switch expressions when you actually want it to fall through, because you can now indicate all of the cases delimited by a comma. Good stuff. You can also do more than just assign values. For example, here, this is where that yield comes into place. We're using a lambda style arrow followed by a set of curly braces to indicate we want to do more than just the assignment. So inside of the body of this case, we add more statements like this one, but the last line of the case must yield a value to be returned. Okay, so if you use this, you can have however many statements you need, do any calculation or processing, and then your final line must yield some assignment. Okay, all right, let's talk about the rules for switch expressions. So you'll need to use the arrows or the colon yield. You can't use both. So line 3 would actually give you a compilation error because it's a different kind of case. Now you can use yield with the arrows, but only in events like the last example I showed you, where you're using the curly braces to execute multiple statements within a case. All right. You can use any of the cases to throw an exception, even, right? So, of course, in this case, no value is being returned for ID. The entire flow is interrupted by the exception. And I put it on the default case because that's where it made sense here. But you can add them in multiple cases, different types of exceptions. It doesn't matter. So, for example, if the case of Mary, I wanted to throw some different exception, I can do that. If I wanted to throw the same exception, I can do that as well as the default one. Okay. So this is not a replacement of the switch statement. This is an addition to the language, meaning you can still use switch statements. And in some cases, that might be the more favorable option. As a rule of thumb, use expressions when you're using switch to assign a value, and use statements when you're not using switch to assign a value, but you just want to invoke some statements. Okay. All right, let's go back to our test. So we're going to go to this get accounts method, which is an API call. So this method is making a get call to all of the accounts for this specified customer. It's then deserializing the response into an array of account objects. And let's go ahead and look at the API response for this call. So notice here we have an array of these account objects, and each account has an ID, customer ID, type, and balance. So I have this Pojo class that has nothing but these fields, as well as getters and setters. And for any of you who have created Pojos, which are plain old Java objects, meaning just some fields and then, getter and setter methods, you know that this is a tedious thing to do. So many people have moved to using, external libraries such as Lombok, so that they don't have to write all of this boilerplate code. But in Java 14, a new construct has been introduced called records. This is a record, much shorter, right? Notice here, instead of using the word class, we use the word record. Also, as opposed to opening this with a curly brace like we would with a class, we use parentheses to declare the fields. So you specify the fields and their data types in this comma delimited list, and then you close it with a closing paren and then the set of curly braces. Okay, and that's it. You don't need to make any getters or setters. You don't need to override the inherited methods of equals and hash code or toString. It's all just done for you. Very nice. However, if you just want to override anything or add any additional methods to a record, you can do so within the curly braces. All right. Good. Now, records can be instantiated just like classes. So account is the name of our record here, and we use the new keyword. We call the constructor, passing all the values. All right. So just like we would instantiate any other object, and the fields of a record are final. So there are no set methods generated for records. And of course, you can add a setter within the curly braces of the record, but I don't really see a good reason to do that since the fields are final and they can't be modified anyway. Okay. You do have accessor methods. However, they don't start with the word get like we're used to. Instead, the accessor method name is the same as the field name. So notice the account.balance call here as opposed to account.getBalance. All right. And records were released as a preview feature in Java 14. That was last March, I believe. And now they are a permanent feature in the language. So, yay. Oh, are they? Maybe not. I might be speaking too soon. I don't think they're permanent yet. I got ahead of myself. Okay, so they're still in preview mode. We got a second preview, I think, in 15. So with it not being permanent, it's available for us to play around, offer feedback. Based on that, implementation could change. So not quite ready to use it in production code just yet. And I gotta double check that. I'm gonna double check if it this stuff is moving so fast, I tell you. So Java 16 just came out a couple of months ago. I got to double check. All right. And I can skip that part. All right. So I want you to see text blocks. So we're going to continue on with the API. And what if instead of calling the API, we wanted to mock the data right here in the API util class? So to represent like this whole thing as a string would be very tedious to do, right? We need to escape all of the fields because they were already in quotation marks, and we need to add new line characters for each line break, and we need to add the plus signs for each line. It's just ugly, right? It's ugly to read, it's ugly to write. Text blocks allow us to use 3 quotation marks to open and close a big block of text. Notice you don't need to escape anything. The individual quotation marks are still there on the fields, and the line breaks are respected. So text blocks were introduced in Java 13 as a preview feature. We got a second preview in Java 14, and I'm happy to announce that they have become a permanent feature in Java 15, which came out in September. Okay. All right. So let's look at some rules and guidelines in regards to text blocks. You cannot include the entire text block on the same line. You're going to get a compilation error. So, in this example, this text is really small. This would have been better as a string, actually, but I needed to fit it all on one slide. So you get a little short one. A new line must be added after the opening quotes, like in this second example here. So this is legal, but this is not the preferred way. There's no balance here. The preferred way is to have both the opening and the closing quotes aligned, and then have the text in the middle of that. Okay. One more thing I want to show you in that API class. So let's say that we didn't want the entire response, but we wanted to just return a hard-coded list of the expected account IDs. The old way of doing this would be to use the arrays.asList method. However, in Java 9, this of method was introduced for all entities in the collection framework. So for lists, for maps, sets, etc. This one seems like a small addition, but I've actually been enjoying it a lot. I think the reason is that it's more natural, right? Before, it took like this small cognitive effort to recall which class do I use, to make a quick list. Is it array? Is it arrays? Which one is it, right? But now I want a list, I call list.of. I want a map, I call map.of. Nice and straightforward. And speaking of maps, populating these used to require a separate method call for each item that we wanted to add to the collection. Now you can define a map all with one line of code. So the parameters are a key followed by value. And you see here, I have 3 entries in this one line. Now, this is me with my wicked one-liner stuff again. I don't actually recommend you make your map there, but I never got to make a map all in one line before, so I had to try it out. But I recommend that you split the pairs on each line. So I would have like 3 separate lines for that, just so that it's really clear which key goes with which value. All right. Now, one thing to note about using the of method is that it creates collections which are immutable. And what this means is that the collection cannot be changed by adding, removing, or sorting the collection later. So only use the of method when your collection won't require any changes later on in your program. Okay. All right, so there you have it. These are my favorite new features from recent versions of Java. I've been using them in different projects. I find them quite useful, whether it be feature code or test code. So, really, really good stuff. What questions can I answer for you?
Angie, thanks for the awesome talk. It was
Yeah.
great. I'm actually, when I started my career over a decade ago, I started with Java, of course, like most people did at that time. And yeah, I didn't quite enjoy working with the language at that point. But yeah, recently, actually, at my company, we introduced a new test automation system, which is built on Java. And yeah, actually, there I actually enjoy coding. But yeah, some of the things you've shown here, the of operator of the or the of methods. I come mainly from Python world, and there are a lot of these elegant, two-letter words in the language. So it just looked fantastic to me. And
Mhm.
let's jump into questions.
Okay. And quick clarification. So I did Google right quick, and records are final in Java 16. So as of March of this year, they are part of the language. So good.
It's great news.
Yeah.
Okay, let's get started with the questions then. They're rolling in fast.
Oh boy.
The first question is from Anonymous. What's the next thing you'd really like to see in Java?
Oh, that's a nice question. Um, what would I like to see in Java? I don't know. I'm going to be honest. I'm feeling like a lot of other developers I'm talking to, and I'm a bit overwhelmed by how, fast we're moving with the cadences. So there's still so much I have to catch up on. What I showed you is only a tip of the iceberg. There's other features in here that I haven't had a chance to play with, or they weren't very useful for me. So I still need to do a little bit more catching up on like some of the pattern matching stuff looks really interesting, and stuff like that. So I'm not asking for anything else until I eat what they've given me.
That's awesome. Thank you for the answer. The
Yeah.
next question comes from Jolt. Do you know if there's a chance that async comes to Java?
Oh, I don't know. I don't know if that's on the roadmap or anything. I'm not sure.
That's fair. That's fair enough. I think it's you can always go to the Java developer forums and take a look at the projects that are happening there. Maybe.
Yeah.
Yeah. Uh, Next question. What do you think about Kotlin as a heavily Java-based modern language? Is it better to still use Java?
So every time I talk about something new in Java, Kotlin comes up, right? And folks are like, oh, Java is catching up with Kotlin now, or whatever. So I think Java is proving to be, just as good and modern of a language as Kotlin is. So Kotlin was developed because of the need for something more modern, and Java is doing the work needed to catch up to that. So I don't think that there's a reason right now to say, okay, we're going to finish Java 8 and then we're going to switch to Kotlin. Like, you don't have to do that anymore. At one point that was the case. If you're doing something like Android development, then maybe Kotlin would be a better approach. But if you're just doing like, back end development or whatever, I think you're good to stay with Java.
Thank you very much. There's another question that I think is asking about Kotlin, so we're gonna move from that. Another person is asking about Scala. basically a similar question.
Okay.
Uh,
Yeah, same answer.
Same answer, exactly. Let's see. Aniko is asking, what is the difference between drop while and filter?
So drop while is going to kind of short circuit the processing, whereas filter is going to look through the entire collection to get what you want. So in the example I gave where they weren't sorted, filter would have went through everyone to collect everything that we wanted to collect, whereas drop while is going to stop when it gets to the certain point, right? So it's a little bit faster, especially if it's already, sorted and or whatever. So the sorting might add a little bit more performance consideration to it. So it may not be as fast if you have to filter, but if you had some like a list and it's like, I just want to make sure like something is in here, right? And so you use, instead of filter, you don't need to get all of them. You want to use a drop while or something like that, or whatever. That probably was a bad example, but you get what I'm saying. Like there's use cases for both of them, in the drop while, take while, or whatever. This will be a faster approach.
Okay, thank you very much. There's another question that I see from Alex. Did you by accident leave out the diamond operators on the slide with the map one-liner?
Did I what?
Did you by accident leave out the diamond operators on the slide with the map one-liner?
No, y'all didn't see it. The hold on.
We're actually checking it. Just FYI everyone, because right now you don't see Angie's screen.
Oh.
Maybe we can pull it up.
No, it was on the right hand side. Oh, I have so many slides. Are you showing me?
Yes.
Okay.
Okay.
There it is right there. You see the string between the brackets, the angle brackets?
Yep. I can verify as well. Thank you. Thank you for looking it up for us, Angie.
Okay.
Okay. In the meantime, by the way, a little bit of a flame war started between Java and Kotlin in the chat.
God.
So yeah, maybe it's a cue. There are no more questions, so I think we can wrap this up. Angie, thank you so much for your talk. It was very entertaining.